Huh? This is not to scale. This thing's not to scale. Okay, obviously, right? Okay, so let's what is our center to center distance?
According to that,
What is the center to center distance? Apply your brain, please.
6.
It's actually the radius of the Earth, correct? Essentially, it's the radius of the Earth. The only thing you'd have to do is add like how far it is to the center of that mass. So go ahead and add like 2 inches to 6.38 million meters. Okay? Yeah? So our radius is 6.38 times 10 to the 6 meters. Right? So this force is going to be 6.67 e minus 11. Right? Times 5.97 e to the 24, right? Times 1. Don't forget to multiply by 1. Divided by 6.38 E6 squared. Now, when you type it into your calculator, try not putting parentheses around 6.38 E6. We don't need more keystrokes. We need fewer. Okay? So you don't need to put parentheses around. It's not going to square the 6 and then do it. Okay? So that's the beauty of it. It's all one number. It treats it as one number. It will square the whole thing. Okay? Type it in exactly that way. Just go divided by, and you can just say, if you want fewer keystrokes, you can just say times, right? Times. You don't need to actually say times 1 probably, right? Divided by, do exactly that. Yeah, that's kind of cool. Except it's 6.67.
Wait, what's the
I don't know.
Oh, you did it wrong.
It's 1.0, I think, isn't it?
There you go. Happy now?
I'm very happy.
Actually, I do have a little question for you, and that pertains to those 4 laws you mentioned
Uh-huh.
earlier. Is it just me, or is it that the weakest one, which is gravity, works over light years? Magnetism, which is the next three, just works over like meters, and it just gets smaller and smaller. Like it's
Well, magnetism would work equally well, in fact better, over light years. It's just that we don't have isolated charges separated by light years of space, right? On the average, as you back away from a planet or something like that, the charge is all neutral. So there we go. Did you guys, what do we expect the force of gravity to be between a 1 kilogram mass and the Earth?
almost 9.8.
About 9.81 newtons, and of course we're squaring an approximate radius, and so we end up with what, 9.78, right? So this is a much more difficult way to do it, yes, but this is what you do if it was like not at the surface of the Earth, yes? Yeah, there we go, right? Okay, so if we're some distance above the Earth, right, then we could figure that out, and we could get the exact force. We could even figure it out for like Timberline Lodge or halfway to the moon, or even if it's not the Earth, what would be the force near the moon, right? Are we all good? So let's do a couple of these, and then I really want to get to orbit because that's sort of the focus here, as it were.